Alright, the first thing we're going to do is we're going to take a look at counting atoms in a compound. So, when we count atoms, for example, if I write a formula as simple as CaSO4, looking at the periodic table, you can pick out the symbols that represent each atom. So, if you know your symbols, you wouldn't have to look at your periodic table. So, you probably will be able to pick these out. Ca is a symbol off the periodic table. S is a symbol, but not S and O together, because S is sulfur and O is oxygen. So we would separate them out when we're counting the atoms. So there's O, which would be oxygen. So when we count calcium, there's 1 listed. When we count sulfur, there's only 1 listed. If there was a number as a subscript behind sulfur at this spot that was like a 2, then we would count it as 2. But there's no number in that position, so we're just going to count it as 1. And then since oxygen has a 4 behind it, that would represent 4 of them. So that was how you count that particular element or that compound. If you have something a little bit more complex, like ammonium phosphate, then it becomes a little bit more challenging to count your atoms. So we're going to list out our atoms like we did before. Nitrogen's 1 with an N. Hydrogen, phosphorus, and oxygen. Remember, P and O are separate elements, and you count them separately. If a compound, like NH4 in this case, is in parentheses with a number outside the parentheses, that free inside the or outside the parentheses would multiply by the subscript. Since N does not have a subscript, then you just multiply that 3 by 1. So there's 1 nitrogen inside that parentheses. You multiply it by 3, you get free. Hydrogen, though, has a 4. So then we would take 3 times 4. And when we do that, we get 12 hydrogens. Phosphorus is 1. And oxygen would be 4. Since the 4 is behind. So that's how you would count your particular atoms within a compound. Also, we have a concept we call moles. Now, moles is equal to a large number, and I'm going to give you the number, but you'll never use it. So if I have moles of atoms here, and I have like 1 mole of atoms, not plural, but 1 mole, then that would be 6O2 followed by 21 zeros. Okay, so we will never use that number. A lot of times it's expressed in scientific notation as 6.02 times 10 to the 23rd. But we will not use this number other than to refer to it from time to time as what 1 mole is equal to. So in our previous example, we had CaSO4. Now if I have 1 mole of CaSO4, then we count the moles as same as we do the atoms. If you remember, we had calcium, sulfur, and oxygen. Calcium is 1. Now, since I have 1 mole of this whole compound, that means I've got 1 mole of calcium instead of an atom. So all we're doing is we're just changing the unit. Instead of calcium, 1 atom of it, we got 1 mole. Sulfur, we have 1 mole. And oxygen, we have 4 moles. So we would count, same as number of atoms, if we've got 1 mole of the compound, we've got 1 mole, or whatever those numbers are, subscripts, of those particular elements within that compound. So that's how you count atoms, and that's how you count moles of atoms. The only difference between counting atoms separately and moles of atoms separately is that mole represents a much bigger number, but your counting would be the same.